Check. How's the sound?
Good.
Can you hear good? Excellent. Keep it on. All right. Excellent. Thank you. Thank you for showing up. How many of you can feel the rumble under your floor? Yeah. See? I'm going to show you some good stuff. Then you will really feel the rumble under your floor. So my name is Arun Gupta. I work for Oracle. As a matter of fact, tomorrow will be my 1-year anniversary with Oracle. Prior to that, I've been with Sun for about 11 years. So my history goes back, when we started J2EE was the very first release of Enterprise Java, and how it has evolved over many, many years. Today, what I'm going to talk about is how OSGi and Java EE can really work very well with each other. How many of you know what OSGi is? How many of you can explain what OSGi is? Okay, so with this presentation, this will be a good mix. Then I will give you an introduction to OSGi. Hopefully you should be able to explain it afterwards. Then I'll dig into why OSGi and Java EE are a good blend, and how GlassFish supports all of that functionality, and why the Vaadin Meetup, talking about all this stuff. So we'll touch all those points. I'm Oracle, guys. So this is a safe harbor statement saying, don't shoot me down if there is any business decisions to make based upon this presentation. It's purely a technical presentation. Talk to Oracle sales guy for making the business decision. Anybody knows what is this? Yeah. This is module Zarya. This is the very first module ever launched, very first successful module ever launched in the space. So this is one part of the International Space Station, which is way up there, hundreds of miles above us in the Earth. This is a live photograph, not live, but a very recent photograph of International Space Station. And in all of this, really what module Zarya fits is just this. So it started with just this, and it has expanded. You can see, almost 20 times of module Zarya, built by 20 different countries. You disassemble ISS, or International Space Station. This is how it looks like. All of these parts launched somewhere from Earth need to go out into space, assemble, and make sure they work seamlessly. The cost of opportunity of not having them work is super high. Now, if you fail, then literally you have to go back down, hundreds of miles, fix it, send it back up again. So the cost of opportunity lost is pretty high. Another example of complexity involved in this project is there were 5 different space agencies. So it's not just technical, it's a political problem too. Now, my space agency wants to do this. That's our stuff. Another idea of a modular system that we're talking about is typically complex. This is probably the most expensive system ever built by human beings. It's about $157 billion. Think of the height at which it's rotating, between 173 to 286, somewhere in that range. All of these satellites or modules are launched from Earth, sent up, and they need to be assembled, while the space station is traveling at 17,000 miles per hour. That's just to give you an idea of how complex a modular system can be, and how OSGi is going to solve that problem for us. Another example of a modular system is, this is a Boeing 747. This Boeing 747 has about 22 miles of wires running inside it, just to give you an idea of one part of the system. Modular homes, yet another example. And of course, this is Nordic, so we talk about Lego, the best modular architecture that I could ever think of, which I love to play with. Now, that was some of the story part of it, but in terms of Java, OSGi really defines a modular system. Essentially, it defines a very clean way for you to define dependencies on different classes that your module needs. So you define your inbound dependencies, you define your outbound dependencies in a very standard way. And OSGi Alliance is a consortium of companies that defines the specifications on how those dependencies can be defined. Now, in terms of what OSGi Alliance provides, like any standard body, there are typically 4 components. There is a specification, which says, okay, this is what my OSGi specification is going to look like. R 4.2 is the most recent release that they're looking at. 4.3 drafts have started coming out. So that's the paperware on what the English text describes. Then you have implementation of it, which is actually Equinox, which is used in Eclipse. You have test suite and certification for an implementation. Some other implementation to be called as OSGi certified or OSGi enabled. Now, what is delivered in terms of OSGi specification? The OSGi specification was originally intended for set-top boxes. That, okay, I have a home network, I want to plug in a device or take out a device. I don't want to bring my entire home network or a home desktop system to break down. I just want to plug in the device should be automatically discovered, I take out, the device is out of service. That sort of stuff. So the idea is to install, uninstall, start, and stop each device dynamically. Now with OSGi specification taking that into Java, we're saying we're going to define a Java bundle which is going to be dynamically started and stopped. Key part, dynamically, because your entire framework is not going down or going up basically with it. And the dependencies between different modules, you know, my inbound and outbound, as I said earlier, are very clearly and explicitly defined. How many of you are familiar with Java Help? I'm sure you experience this every day, you know. It would be good to have a term called as jar heaven. Nobody uses that term. But the idea is, jar is really a built-in dependency. It's a built-in artifact. You compile the classes, you build a jar, and that's the unit. However, when you are including jar in your class path, my Java compiler or my Java runtime takes the jar, all the jars, flattens them out, and it puts all, you know, depending upon the path or depending upon the sequence in which you include the jar, you have all of them in a flat class pattern, and then it searches through that. How does it handle multiple jars, multiple versions? Well, too bad. I'm going to take the first one. That's what I care about. That's how I run it. So there are certain known issues with jar, and there is no metadata to indicate dependencies. Support multiple versions, for example. You cannot do that. And this is the biggest problem. All public classes are public. Hey, you know, you put that in a public class, so that means it's available to me, it's exposed to me. So you put that public class because you wanted it to be used from other packages in your jar file. But you did not say that other packages from other jar files cannot use it because that's public. So there are sort of known problems with jar dependencies over here. OSGi tries to solve that problem by defining a well-defined model. It defines, you know, 4 different layers basically. It says there is a service layer, there's a lifecycle layer, a module layer, and an execution layer. So OSGi bundle, the terminology that we talk about all the time, is essentially a jar file with clearly defined boundaries. And then, so we have an OSGi module that runs on an execution environment. The execution environment is typically, in our context, is JVM. Each OSGi bundle or module, I'm going to use that term synonymously, has a certain life cycle. The bundle is starting, the bundle is stopping, so on and so forth. And each bundle can expose multiple services. And services is a very, very well-known concept in OSGi land, and we'll talk about it, how do we use those services in the Java EE context. So OSGi bundle, as I said, is nothing but just a jar file. I got all my jar process static files, like my JSPs and all that stuff, you know, my CSS, my HTML, they're all living here. Then I got my manifest information, which is the most critical information required for OSGi bundle, and I can put some optional information in this package too. So if I look at my manifest information, that's where I say what my export package is going to look like. That means these are the outbound dependencies. So I'm exporting these packages explicitly. So yeah, I mean, I might have multiple classes in my jar, but I'm exporting these specific packages or classes. And I'm going to depend on a specific list of packages and classes as well. And then even within bundle, I'm going to define what my class path looks like. By default, everything is private. You have your classes public, but the OSGi runtime is kind of figures out, looking at this manifest information, what your bundle looks like really. Each bundle is persistent, so you have this OSGi bundle, and then you have this concept of OSGi runtime. Now you deploy the bundle, and the runtime goes down, then the runtime comes back up. It understands that the bundle has been deployed, so it starts back automatically. So it's persistent. It saves the state across multiple restarts of the OSGi runtime. Apache Felix is just one runtime. Equinox, as I mentioned, is the reference implementation of OSGi, so they all support these properties. And then each bundle is atomic. What does that mean is, either the bundle is deployed or not deployed. There is no maybe state for a bundle. So I'm going to give you a brief introduction of OSGi, then we'll jump. So let's see how a bundle is identified. So I got my jar file. Take any jar file, just put the meta information over there. That becomes an OSGi bundle, and there are standard tools available for that. Modular plugins, and scripts, IDEs that allows you to convert a jar file by specifying certain information and converting that into an OSGi bundle. Now each bundle, of course, has a bundle identifier, which is stays unique for the lifetime of the bundle. So you install a bundle, it gets a unique ID, and that is unique for that bundle. If you uninstall the bundle and install the same bundle again, you get a new unique ID. That's an important aspect to remember. Each bundle has a location, which is the physical jar file where it's living, and then each bundle is given a symbolic name and version as well for convenience. So let's take a look at it. Now I have a jar file in which I have an export package. I'm explicitly saying, okay, these are my explicit dependencies. So in this bundle, I'm exporting a service. So maybe in the export package, I have a service, and I'll talk about how we export the service. I'm exporting a service, which is coming over here. In my client bundle, I have an import package. I'm going to import this package exported over here. So even though both of these jar files have a whole bunch of public classes, but by putting explicit information, I'm restricting the scope of the classes in an OSGi runtime. So it's an additional layer sitting in your environment somewhere, but you know what the explicit dependencies are, and OSGi runtime, in that sense, honors it. So export and import is a one-on-one relationship. Now in terms of how does the interaction work between different layers, I have an OSGi bundle. The first thing I do is I want to start and stop a bundle. So I say, in order to start and stop, I need to install the bundle. I install the bundle, then it starts the bundle. The bundle figures out, okay, it's basically a bundle, so I need to load the classes that are required to get the bundle ready. It looks at my execution environment, which is, in my case, Java JVM. And then, through the life cycle, we can manage the several services as well. And those services are then either registered or unregistered, or get or unget by different bundles. We talk about a server bundle and a client bundle. That's how it's done, which is what I explained in the previous slide. And of course, the bundle gets executed in the execution environment. So let's take a look at the bundle state diagram. Now you have a bundle, and what are the different states I talked about? Is a binary state. It's a black and white. There is no gray in between over here. So you have a bundle. You say install the bundle. So then bundle goes in the installed state. From the installed state, it looks at all the dependencies that it cares about. So in your bundle, you might be saying certain import packages and stuff like that. So it looks at the OSGi. It asks the OSGi runtime, can you resolve all these dependencies for me? If yes, then it says, okay, I'm in resolve state. All the dependencies resolved. If not resolved, it throws an error back, and the bundle is not even deployed. So it stays back in the install state. Once it's installed, then you need to explicitly start the bundle. So it goes into starting phase for a little bit, and then right it becomes active. Then you can explicitly stop the bundle, in which case it goes back to the resolved state, and finally you can uninstall it. And as I said, if an OSGi bundle is uninstalled and is installed again, is a brand new bundle ID that it gets. Each bundle can be updated and refreshed. However, in that case, the bundle ID still remains the same. So some basic OSGi concepts for you to understand. The advantage of doing that is this helps you build a modular application. Think about your application as MVC architecture, very common architecture. So think about your model being one OSGi bundle, view being another OSGi bundle, controller being another OSGi bundle. Each of those applications possibly are exposing a whole bunch of services. The controller is exposing a service that's being used as model, and vice versa. So each of these could be separate services. So the dependencies are very clearly defined. You know what model is going to do. It goes from view from controller, and vice versa. And then what happens is your deployment time becomes super fast. Instead of deploying one full shebang or like a 10 megabyte WAR file, let's say only your controller has updated. So you just drop the container jar file in there, which is your OSGi bundle. Only that thing gets updated. All other services are dynamically tracking that bundle and they refresh themselves. As part of update refresh, of course, the resolution happens all over again. So in terms of the OSGi containers, there are three main containers that are mostly prevalent. Phoenix and Equinox are the most prominent ones. Equinox comes as part of Eclipse. Phoenix is from the Apache community, and there is Modular as well. And as I said, Equinox is the reference implementation. So when they wrote the specification, it was implemented in Equinox. So the Eclipse IDE is built on top of Equinox. It's a OSGi. It's a perfect example of an OSGi framework, how it works. I mean, you guys are probably familiar with it. Each Eclipse functionality is an OSGi module, and that's the way it works. So let's talk about, what is the relationship of OSGi and GlassFish. So was that a good introduction, fast-paced introduction to OSGi? Okay. Question? You have a question? Oh, that was yes, that was a good introduction. Okay, got it. Right, so let's see, what is the relationship of OSGi and GlassFish, essentially. Now, GlassFish is the reference implementation for Java EE6. How many folks know about Java EE6? Excellent. How many folks can explain Java EE6? See, I like that big question. So anyway, maybe let me spend a few minutes on Java EE6. So this morning I gave about 3.5-hour tutorial on Java EE6. So that was super cool, and I'm giving 2 more talks at JFocus. One on how to run Java EE6 applications in the different cloud environments, and one on Java EE6 tools. That's a purely slide-free talk. Just open up the IDE, let the IDE do the talking. But for your summary, since you are in a special cruise ship in a Vaadin Meetup, I'll give you a quick shot. Java EE6 is the latest version of the enterprise Java specification. There are 3 big themes for Java EE6. First is to make the platform lightweight. So over a period of years, the platform has evolved with multiple specifications. There are about 30 plus specifications now. Not all the specifications are required for a modern web development. So we have created something called a web profile, which is a subset of specifications targeted towards modern web applications. So literally we have a handful of specifications included in that. So GlassFish, which is a reference implementation of Java EE6, comes in 2 flavors. There is a web profile flavor and there is a full platform flavor. Just to give you an idea, the difference between the 2 implementations, the web profile flavor is about 33 megabytes. In that 33 megabytes, you get your JSPs, servlets, APA, JSF, context and dependency injection, all the specifications that are part of web profile. The full blown is about 70 megabytes, so 33 and 70 megabytes. Now, depending upon what you want, you can download that. That's the first part of it. We're also adding this concept of pruning existing specifications, such as JAX-RPC, JAX-R, the specifications that are no longer relevant to the platform. So define a 2-step pruning process, mark them for pruning now, make them optional in the next release, and delete them in the next one. That's the lightweight part of it. Second is flexibility part of it. Make it agile and make sure that we embrace other open source frameworks as well. So for that, we're adding a whole bunch of functionality by which it allows you to embrace those open source frameworks. How? So let's take an example of Wicket. So if you're using Wicket as part of your Java EE application, let's say you want to use Wicket widget toolkits, widgets as part of your Java EE application. Now you will have to register your Wicket filter, and you will have to put the path in there, in the deployment descriptor and stuff like that. Well, that becomes tricky if you're using more than one framework. Even one, I'm an application developer. Why should I be concerned about what your framework needs to register? So what we're saying is, we're turning the engines. So what we're saying is, you know what, you are the framework developer, you know how this registration needs to happen. So instead of me putting that registration code as part of my application deployment descriptor, I want Mr. Framework Provider, in your jar file, I want you to put meta in. In that meta in, I want you to put webfragment.xml, exactly the file name. In there, you give me the registration code. Then if I'm running a Servlet 3.0 compliant container, that will automatically register your framework for me. So the idea is to make it simple, keep your code clean wherever the responsibilities of due separation of concerns. Second part of it. So make the platform lightweight, make it extensible, and third, which is the biggest focus, is really ease of use. We're making deployment descriptors like web.xml, basic config.xml, purely optional in most of the common cases. Those are being replaced by annotations. We have also introduced a version of EJB in a WAR file where EJBs can be easily packaged in a WAR file. You don't need special packaging or features like that. Basis.config.xml that typically would have your default navigation rules. You will have a whole bunch of things over there: validator, renderer, listener, then the corresponding annotations over there. So those are the sort of big three themes: simplicity, extensibility, and ease of use. Now, in terms of GlassFish is a reference implementation, as I said. What we use is GlassFish runs on top of OSGi. So once you download GlassFish, everything, each functionality in GlassFish is an OSGi bundle. Web container, that's an OSGi bundle. EJB container, that's an OSGi bundle. Web services, OSGi bundle. So there are about 200 plus modules that come with GlassFish, each of them being an OSGi bundle. And it starts on demand. Because of OSGi, when GlassFish server is downloaded and you start it up very first time, it knows what kind of applications are deployed. Well, by default, there are none. So it starts up in a few seconds. Well, the first time it takes about 7 to 9 seconds because it's creating log and cache files and stuff like that. But then onward, it literally starts up in 2 to 3 seconds because there are no applications deployed. Now, when you deploy your very first application, which is a web application on demand, that gives you efficient utilization of your resources. If EJB container is not required, it won't even start it. If your security is not enabled, it won't even start the security container and things like that. So it's a full utilization of your resources. And that's possible because the dependencies are very clearly defined. It knows exactly what needs to be started, what does not need to be started. All right, so we talked about pretty much all of it. Now, we use Apache Felix as the default runtime, which is bundled in there, but doesn't mean it's restricted really to just Felix. We can run it very well, for example, on Modular and Equinox. Taking it a step forward, let's say you have Apache Felix or any OSGi environment running in your already existing deployment, you can start GlassFish in that because essentially that is also a OSGi bundle. So Felix, start a Felix, run GlassFish in there, or start a GlassFish which runs Felix in there. Both ways are possible. So if we take a look at the architecture, at the bottom layer, what you see is our execution environment that I explained earlier. Then on top of that, we have our V3 core, GlassFish core engine, which is our module subsystem, and we have a Grizzly framework, which is our front-end framework. Then we have the OSGi layer, which really has a whole bunch of services. Okay,
So configuration is a service, deployment is a service, management is a service, clustering is a service, injection is a service. So each of these are really exposed as OSGi bundles and OSGi services. Now we have more services built upon these basic services, which is like management command line interface. I have my web-based console, which is in turn leveraging these basic services to provide more, composite services, so to say. Using those services, I have defined this concept of an application container. Now this is a much more abstract layer where I say, okay, you know what, my application container can config, deploy, security, monitor, cluster, and a bunch of other functionalities. It exposes those intersection points. Similarly, I have a bunch of those application containers, essentially. So I have a web services interop container, EJB container that's exposing all of my config, deploy, it's basically implementing those points, and you have that functionality in there. So what happens is, let's say you have your OSGi or your GlassFish running already, you want to enhance the functionality, you just implement the application client container, which is implementing those specific points, drop a new jar file, no need to shut down GlassFish, the functionality becomes available to you instantly. So that's pretty cool. In terms of how does it work for OSGi bundle management, well, we of course have the simple OSGi bundle management layer at the bottom. What we also do is, now even though we're using OSGi for class loading and everything else, but there is an abstraction that we provide on top of OSGi, which is really our core SIP system. So we use the HK2 APIs. HK2 is our 100 kilobyte kernel, really lightweight, really efficient kernel, which can use multiple modularity mechanisms. So OSGi just being one of them. So tomorrow, if a new modularity mechanism comes in, we can just provide that abstraction layer on top of that, and HK2 will just continue to work as is. So we have a HK2 service layer, which is basically your OSGi v3 modules, or GlassFish v3 modules, plus extra metadata. However, in terms of bundle management, you can take a random OSGi bundle, create it elsewhere, drop it into the GlassFish environment, and that will work too. So you can create a OSGi bundle using NetBeans or Eclipse or Maven or whatever tool you like. Once you create the bundle, you drop it in there, and it just behaves like a perfectly normal OSGi bundle. So in terms of modularity, let's see what were the key benefits to us for using OSGi. Well, first of all, it actually enforces much stronger modularity. What that means is, we work in a distributed team. We guys are all over, like Santa Clara, we are in Boston, we are in India, we're in Paris, we are in London, we are in Prague, all over. It's a global team, global time zone. So how does it help? Hey, I can just look at purely at what import and export package metadata is and rely upon that. Implementation goes wrong, whoever is implementing that interface, that's his or her problem. That basically ensures it's much stronger modularity because everything is reliant upon that. Now believe me, that exercise to begin with was not easy. We had a lot of finger pointing to begin with, but we learned our lesson. And so if you kind of start in that direction, there will be some of that. But one thing I love to say, treat your issues coldly, people warmly. Most of the time, teams fail because they reverse the roles. They treat issues warmly and people coldly. I don't care, just fix this issue first. It doesn't work. Again, treat your issues coldly, people warmly. So, in cases like this, that's what really helped us. Now, because of that OSGi bundles, it allows us to create a custom-tailored app server. I can remove an OSGi bundle. I can add an OSGi bundle. I can create a fully custom-tailored app server for my customer. I can change the look and feel because those are essentially all extension points and well-defined dependencies. As I talked about, we're using lazy loading based upon usage patterns, what applications are deployed, what containers need to be started. I start them accordingly. Higher utilization of your resources, much quicker response time for the clients. And because the dependencies are defined, we could actually deploy not just JVM or Java-based language, but we could deploy any JVM-based language applications. So for example, on GlassFish, you can take a Ruby on Rails application and deploy it. You can take a Grails application and you can deploy it. You can take a Django application and you can deploy it. So following that standard best practices allows us all that mechanism. And the key part is we successfully maintained very quick startup because we knew exactly what needs to be started and what can stay back. And another benefit that I talked a little bit earlier was, yes, GlassFish kernel is using lots of OSGi stuff, but it's available to you as a developer. So you can create a random OSGi bundle and drop it into the GlassFish environment, and it will behave as a perfectly fine OSGi service. There will be no way for users to figure out whether it's part of the GlassFish core that can be downloaded, or is it something that you have written, because they work very well, interoperate very well with each other. So in terms of how do you create an OSGi bundle, very simple. There are a few ways. You can create a Maven project in NetBeans, and then as I talked about, OSGi bundle has a life cycle mechanism. So each OSGi bundle, in the OSGi bundle, you can implement something called as a bundle activator, which is a start and stop method. In those start and stop method, you potentially register a service, and in stop, you can optionally unregister it. Otherwise, OSGi runtime takes care of it automatically for you. So then you update your POM XML, add your dependencies, go through the Maven configuration, and then you fire the bundle. Now I got a lot more details on this blog over here on how exactly you can go through all of this to create your bundle, and I will share the slides on my blog tomorrow. This kind of gives you an idea of how do you do that using NetBeans, or you can create an OSGi bundle natively. That was the POM mechanism, Maven mechanism, or in NetBeans you can say, you know what, I'm going to create a new OSGi bundle itself. You can just check mark generate OSGi bundle, and it generates all the metadata for you. You can also specify the configuration information in your POM XML in the previous case, and then accordingly it figures out what classes need to be exposed. So those are some of the key points. You define the POM dependencies, you define what the meta information it needs to take, and then based upon that, it generates your manifest information in the jar file. Now in the OSGi bundle, as I'm generating still a Maven OSGi bundle, I can say, okay, you know what, create a new bundle activator, which is what I'm going to use for all my service lifecycle mechanism. So if I can take a quick break here. So if I go down here, loading. Okay, so this is the manifest information. That's the way it's generated for me. I can have a bundle symbolic name, bundle localization. There's full support for localization and all those things. Then I'm saying, okay, add a new bundle activator over here. This is how my bundle activator looks like. You know, it implements this interface. Then I have a start and a stop method. In there, I typically register my service. For now, I'm putting system out printlns over there. And when I'm doing create npm, there I say, oh, by the way, generate a OSGi bundle for me. Or I can say OSGi build bundles. And once that is ready, I want to show you how my meta information looks like. Yeah, this is how my meta information looks like. In here, I'm saying, okay, what my bundle activator is. So you point to a specific class, and then you're saying import which all packages. In this case, I'm exporting a specific package. So here, for example, maybe I'm having a service that is being registered, and the bundle activator automatically kicks in. So you're explicitly what you're doing is the typical design pattern that we follow is you have an API bundle and you have an impl bundle, because API bundle typically is not being updated that often. You can keep updating your impl bundle, which is the implementation of the service. You can update that as many times, and it is being dynamically tracked. Yep, this is what I just showed. Oh, this is actually using Eclipse. So in Eclipse, of course, Eclipse is anyway built on the core of OSGi, so you can very easily create an OSGi bundle. There are different ways by which you can deploy these OSGi bundles in GlassFish. You can do ASAdmin, which is a command line utility, deploy and specify the type. You can just do simple file system based operations, copy and remove the bundles, and then they're dynamically started. You can tell them to localhost, and then gives you OSGi shell, or you can use Apache Felix web console. The beauty of OSGi is you can extend it using OSGi. So somebody actually wrote a REST console bundle. That's again yet another module that you add to GlassFish, and it gives you a RESTful interface to manage your OSGi shell. Somebody even wrote a Perl-based shell, Visual VM plugin, and all different mechanisms are available for you to install and manage your OSGi bundles within GlassFish environment. This is a sample of which is integrated into our administration console. So we have an Apache Felix web management console. So you can this is a graphical interface, install, update the bundles, and it shows different statuses over there. So let's see, we talked about bundles, we talked about how they work in GlassFish. Let's see how the dynamic discovery of OSGi service works for me. So in my start, I would, as I said, I would register the service, and stop, I will unget the service. So here, as I said, I have an API, impl, and a client. 3 bundles I got. Now API is exporting, impl is importing, and similarly client is also importing the API package. In both of these, I potentially have bundle activators, an impl and client. In the bundle activator, what I'm doing is I'm registering my service with the OSGi service registry. And then in the client, I have service tracker that allows me to dynamically track the status of my service. As I said, each bundle throws events. So it basically uses those events to tell my client, oh, service is up or down, and then behave accordingly. So that's sort of a typical design pattern. API, impl, client. Impl keeps updating multiple times. You don't want to change your API. It's always cost to change your API. And in the service tracker, you can apply filters. Oh, I want a service that meets so-and-so criteria. You can set up certain quality of service attributes easily. Let's explain much more detail on the blog. So why OSGi in enterprise applications? First of all, it gives you improved modularity. As I talked about, splitting your application in different bundles. Your deployment time really reduces drastically. You can have dependencies much more visible. I talk about better version control. So since you are saying, okay, I want to import this package, you can restrict, there are regular expressions that you can define in your manifest saying, I want this version. So imagine you could have multiple log4j jar files in your OSGi environment and point to a specific jar file. You no longer have to say, oh, you know what, it's a flat class path. That is no longer an issue for you. There are much better tools for development, primarily because of the ecosystem around it. The lifecycle is much more observable because each bundle, start, stop, install, uninstall, is throwing events, which are well-known events. You can dynamically track the service. You can even say criteria-based service selection. But why Java EE in enterprise applications? I'm not going to go through this, but idea is we have well-proven component models. Be it JPA, be it JTA, be it JAX-RS for RESTful web services. We have so much better frameworks. I mean, these are standard known benefits of enterprise applications. The beauty is we can merge them together using OSGi Service Platform Enterprise Specification. These are basically a bunch of specifications, literally RFCs or request for comments, and they define really how OSGi should work in alignment with different Java EE6 specifications. So they define requirements for extension to the OSGi. The typical model is you publish a service, you find a service, and you bind to the service. But this specification defines how you can extend that model and make it more richer. It allows integration of established Java EE technology into OSGi. It allows distributed federated service model for Java EE applications. So a hybrid application is really application that is both an OSGi bundle and a Java EE application. So in terms of roles of GlassFish, really provides a runtime for hybrid applications. You can, we call it as a web application bundle, so to say. You can deploy that application seamlessly. And the way it works is you can take a WAR file and you can deploy it to GlassFish using a scheme called as web bundle, and it automatically generates a manifest information for you based upon some defaults. In GlassFish, we implement all the Java EE related OSGi services. You don't have to assemble the bits, as I was talking about, web bundle. And OSGi is exposed to you as a developer. So let's look at some specific use cases that are being used to solve this problem. This, by the way, is a list of RFCs that we have implemented in 3.1. So for example, my web application bundle, all I have is a WAR. This is also an OSGi bundle. All I specify in there is my web context path. So let's imagine my OSGi jar has a servlet in there and a bunch of other files, and I want to expose this as at a particular URL. I just put web context path at this URL, and I deploy that. So now you have a hybrid application exposed as OSGi bundle, going through all of those lifecycle management events that I talked about, and also exposed as a WAR file. This is another cool part, OSGi declarative services. So the complications over there really are, it's a long startup time because you keep tracking which service is up and down. So there are issues in OSGi. OSGi is not really a be-all, end-all. It's not the perfect solution. It has its own issues. It's got a very complex service programming model. Dynamically tracking service requires you to solve certain issues. So that's an issue with it. Now, however, what we are trying to do is we are trying to simplify that entire model by providing you simple annotations. So let's take a look at that. So how does the OSGi declarative service really work? Well, we have an API, we have an impl, and we have a howdy impl. Let's say an API has 2 impls. We of course have an export package, or both the impls use that export package. In my OSGi service, or in my jar file, I'm going to define a service components.xml, and I have a hello impl, which is implementing this service, which is coming from the API package. And then in my servlet client, all I can do is I can say add resource map name hello service, which is the name that is mapping right over here. So instead of writing all that boilerplate code, you can just say, you know what, I'm just injecting it as a resource right over here. So we have, some dependency directly with your Java EE code that works very well. So in your impl, all you do is you put single annotation, and then all that meta information is automatically generated for you by the Maven bundle plugin. Another use case. So let's say we have a JAX-WS endpoint. You have a business method implemented over there. The typical way it works is that exposes a WSDL. WSDL generates artifacts, and then you have your client-side stuff, which then talks directly to the endpoint. Now, how do we evolve that model? Okay, let's take the same thing again. All I'm going to do is I'm going to have an OSGi bundle. My business method actually is implemented in the OSGi bundle because I want to have a more observable lifecycle, more dynamic. In here, all I do is a delegate. In this business method, this is the OSGi bundle, so I register my service over here. This delegate is basically my OSGi client. It queries the registry, gets the service, and then talks directly to the business method. So some of the use cases on how you can mix and match different Java EE technologies and OSGi bundles. One more. You have an OSGi and EJB. How do they work? Well, I got an API, I got an impl, and I got a load data method. So load data will load data to my database. Impl will, for example, read the data from the database and expose it to my service. Now in my API, I have, of course, export package. In impl, which is my EJB, this is, let's say, my traditional EJB application. If I want to export an EJB, all I do is add this annotation. Now this annotation is specific to GlassFish, but the idea is the moment you add that annotation, that EJB is automatically exposed as an OSGi service for you. Registered into OSGi service registry, which can then be invoked by any OSGi client. Yeah, so you can put this export EJB in your meta information, all, none, or specific names, and that will be automatically exposed to you. Advantages, you get all of these benefits in an OSGi together. I'm going to skip this use case. Well, essentially what it is, we have a producer and a consumer in JMS land. In consumer, I'm not exporting any EJB. In producer, I have a bundle activator that registers my service in the service registry. In here, I can specify certain attributes, destination, connection, factory messages, which then registers, so anytime a message is being generated, it's being put into the queue, which is then consumed by my consumer. This is a very cool example actually. So in here I have my GlassFish runtime. I have a service, for example, implemented in the Spring container, which is by the way another OSGi compliant container, and I have my Java EE web application that is actually a hybrid application using the OSGi runtime to access the service implemented in my Spring container. So you can mix and match. My Java EE web client is good, my Spring-based services are okay, so I'm going to start a piecemeal approach to take it and implement that. This is the last example pretty much. So same example that we saw earlier. My API, my impl, my client, export, import package, service registry, service tracker. But here for service tracker, we have to write a whole lot of boilerplate code. All we are saying is, instead of writing that boilerplate code, you just say add OSGi service, then the CDI extension that we have written will take care of doing all that boilerplate code for you. This will automatically, dynamically track the service for you. So essentially, my code, which used to be like this, service tracker, new service tracker, tracker open, get service, and invoke it. I mean, this is super trivial. Otherwise, you have to listen for the events and all those things. I'm just saying add inject OSGi service, and then it dynamically tracks the service for me. In terms of JPA, I got entities that can be exposed as JPA as a OSGi bundle, and it generates all the required meta information for me. Other OEE resources are available as OSGi services as well. This is a lab that I did, me and Sanjeev did last year at Java 1. It shows how OSGi client can invoke an OSGi service, OSGi client can invoke an EJB-based service, and a web application-based bundle can invoke an OSGi service. This is the last slide. So this is the slide that I borrowed from the Vaadin website. There are different deployment models of Vaadin. So one is, you have a var in which you have a Vaadin application and Vaadin library. So this is one big var, one big deployment. The other deployment model really is you have your web container within which you have a Vaadin application, and the Vaadin bundle can be deployed as an OSGi bundle by itself. There are OSGi compliant bundles already. Or think about, instead of OSGi container, think about this as a GlassFish container, because this is OSGi compliant. So not just your Vaadin bundle, but your application bundles are OSGi bundles as well. So your deployment time, all of those become super efficient. The data point that I got from the website is 5 times faster deployments. That's the typical advantage that you see out of it. All right, so I'm pretty much going to be kicked out of the stage if I talk anymore. But I'm going to be around, and I'm going to be around for next 2 days. If you have any questions, I'll be happy to take them then, not now. Thank you.